Do you think you know how the world works?
Something's going to happen.
What? What's going to happen?
Something wonderful.
What?
Do you think you know how the world works?
What's going to happen?
Something wonderful.
My God, it's full of stars.
To show you just how much you don't know. Open your eyes.
So I've been doing science for a long time. I've been a research scientist basically my entire adult life, some 20-something years, and it's still humbling by just how little you know and how easy it is to get into the position where you can take a very simple system and look at it in detail and not have a clue what's going on. And it's not just me. I could take this video, in fact I have taken this video into a room full of people with PhDs and professorships, that sort of thing, and none of them had a clue what was going on. And it's all the more interesting because this system is so simple. It's just an alkali metal like sodium or potassium, or an alloy of the two of them, and ammonia. And now ammonia is kind of like water, only it's nitrogen rather than hydrogen. So rather than H2O, it's H3N. Now, sodium-potassium alloy explodes on contact with water, but not so with ammonia. Here, the metal dissolves into the ammonia to give solvated electrons and sodium ions. And at higher concentrations, this gives this gold or bronze-colored solution. And at lower concentrations, it gives you these deep blue solutions. And just so you know, all the close-up stuff here was done with a microscope, so the entire field of view is about 10 millimeters, about half an inch or so. So with things like this, you're looking at a single drop of sodium-potassium alloy. Now, ammonia boils at about -30 Celsius, which is also about -30 Fahrenheit if you're into that sort of thing. So it boils off pretty quickly at room temperature. So a lot of what you're looking at here is you've got ammonia gas passing over the alkali metal. Now, of course, at room temperature, it's a gas. And then as you cool down the whole system, the alkali metal gets down to the temperature where the ammonia starts to condense to liquefy on the surface of the metal. And at that point, it goes golden. And then the weird stuff starts to happen when you start raising the temperature and the ammonia starts to evaporate off. And sometimes you get these dendritic growths, some of which are beautiful, but none quite as beautiful as you get with lithium, where you get an absolute garden of silver thorns which turn golden when you add the ammonia. Now, sometimes those dendritic crystals are huge, but why do they form and why so quickly? Well, that's actually a much trickier question than you might think. I suspect it's got something to do with the weird surface tension, this solvated electron solution. And just so you know, surface tension's essentially what makes water droplets round so quickly. You see, even though that gold solution has almost all of the properties of metal, in that it conducts electricity better than copper, and it's shiny to the point where its reflection is just creepily perfect. I mean, what you're looking at here is just a reflection of the bubbles in the cold bath. However, it's not got the high surface tension of a metal. Virtually all metals have very high surface tensions, but not this one. Now, those dendrites are very similar to the ones that grow electrostatically in batteries.
This dendrite, which grows inside of your battery, can lead to two major issues. First, it reduces efficiency.
I'm not quite sure if these mechanisms are the same or whether they're merely cousins, but the dendritic lithium crystals that you get in batteries is the sort of thing that shorts them out and makes this happen.
Because they're metal, they can form little wires internally inside of the battery that can short circuit the battery. This can lead to significant safety concerns, such as formation of fires, etc.
Yeah, all of a sudden that random, I don't know what I'm looking at, but it looks cool, which becomes a moment which may actually lead to an understanding which will have an application. Because if you understand what causes these dendrites, then you might be able to do something about it. Another place where you can see this low surface tension, which I can't prove yet, but suspect is critical to a lot of what you're seeing here, is when the eye opens. So that's a metal ball of sodium-potassium alloy there in the middle, and it's got this metalloid solution sucking up the side of it. And there, that bit where the sort of gold solution sort of shoots across the metal surface, that happens blisteringly fast, to the point where I would need to get the high-speed camera out to work out just what's going on there. Now, what the hell are you looking at here? Well, this one I can actually explain a little better. So you start off with this sea of gold metalloid solution of ammonia with solvated electrons and metal ions. But as the ammonia boils off, the metal starts to crystallize. Yup, you can actually see the sodium or potassium crystals growing there. Again, something that might have interesting applications if you want to grow sodium crystals. But there's clearly a sealing event, which I don't understand, but the fast movement of the little particles here I can probably explain. As the ammonia evaporates off, there's these little tiny gas currents on the surface of the solution which give you this enhanced Brownian type motion, which you can then see because of the little sodium crystals floating around on the surface. And for those of you who want to know how my last video fared, well, so far it was monetized on day one, and on day one it went demonetized, which I then appealed, and about a day or so later it went to monetized again. Whoopee! Then a few hours later it went to demonetized again, but was then marked as under review, even though I hadn't submitted it for review again. And there it stayed like that for a couple of days, and now it's back to monetized again. But seriously, YouTube, why does a simple science video get demonetized twice? Practical upshot of this, of course, is the first few days that the video is up is when it gets most of the traffic. And out of the 5 or so days that it's been up, it's been demonetized for about 80% of the time, which basically means I get almost nothing for it. Which is a shame, because not only is this video beautiful, it's, as far as I can tell, an undocumented phenomenon. So yeah, a big thank you to everyone who supports this channel through Patreon. Because while YouTube has been happily demonetizing almost everything, including beautiful science videos, it was good to know that there were still people out there who support the work that this channel does.